radian measure. In grade 0 to 11, you work in degrees. Okay? From grade 12, for almost the rest of your math or university time, if you're taking any chem or you're taking physics, you work in radians. So believe it or not, degrees are very inaccurate. Okay? Radians are what NASA uses, what any engineer would use. If there's anything with the circumference or anything like that, obviously when you're dealing with rotations and all of your astronomy, I mean, I took an astro class in university and it's all deals in radians. It doesn't deal in degrees. Okay? So degrees are the high school stuff. Okay? Radians is all grade 12 and university. The hard part is making that transition because you're so good at degrees. Like you're just so good at them, and now you're going to make me do something that even though it's going to be better for me in the end, it's really uncomfortable. So if we do it this year and next year, it won't be new for you next year and it won't be as uncomfortable. Okay? So it's kind of like you've learned a bad habit and we got to get you out of that bad habit of learning degrees. And it's really, really hard, as you know, no matter what habits we have, it's hard to get rid of habits, right? So that's going to be kind of what we're going to be doing the next 4 classes. Okay? Now, the first thing we're going to talk about is what is a radian. Now, here you have a circle, and as you remember now, and we're going to do the other good thing about this is as we're doing this trig unit, there's still a lot of stuff that we're going to be reviewing from the trig unit we've done already this year. So that'll help you towards your replacement test coming up and your final exam. So we are killing 2 birds with 1 stone. We're going to make radians way easier for you next year, and we still are going to be reviewing the trig we just did. All the unit circle, right? All the root 2 over 2, 1/2, root 3 over 2s, those numbers. We're still going to be working with them. Now I've given you a unit circle, so we can be learning them again as we're going through this. Now a radian, and the radian is actually so simple that if you, I mean, people think of a degree as really simple too, like it's just one little, like there's 90, so I know where 45 is. But a radian actually is a piece of like a piece of a pie. That's all it is. But it's very unique about it in that, say this is 3 centimeters. Now obviously, because what I just drew is another radius, this would be 3 centimeters. But an actual radian, this would also be 3 centimeters. So a radian is where all 3 sides are basically the same length. Okay? Now this is called the arc. It's not a straight side, but it will be 3 centimeters. So if you took a piece of string, they would be, Lucas, you with me, writing this stuff down? You would be taking a string, and there'd be 3 centimeters each. And this is roughly about 60 degrees. That's a radian right there. That's what it is. Okay? So it's not a complicated thing, but when I start taking chunks of that radian, then maybe that's where you'll see the... Now in a half a circle, how many radians, just by an estimate, how many radians would you see? I didn't draw that very straight. How many radians do you think are in half a circle? 3. Actually, specifically, 3.141592. There's actually, what's another word for 3.14159? Pi. There is pi radians in 180 degrees, or half a circle. So what's a radian? It's a piece of pie. There are 3.14 pieces of pie in a half a circle. How many radians in a whole circle? 2 pi radians, yes. There, which is 6.28, right? So there is 2 pi rad equal how many degrees? 360 degrees. See, even having this exposure, next year, you're not going to be, like when I go, yeah, there's pi radians in a thing, you're going to go, yeah, I remember that, okay? So, it's like 1, 2, 3, 4, 5, 6. So roughly 6 pieces of pi in that pi, okay? Because there's pi radians in half a pi. And what would be the angle? Approximately 60 degrees. Now, we're just going to, so I've talked about all this just in the diagram. Let's go down to the bottom here, because today we're going to be dealing with both. Okay, because in grade 12 what you have to do is you're weaning students off of degrees onto radians, but you still hang on to them a little bit. So as you can see, pi radians equals 180 degrees. Remember, that's 3.14 pieces of pi, right? A radian is a piece of pi. So there's 3.14 pieces of pi makes up 180 degrees. So there's a formula that we can use that if you want to convert from degrees to radians, multiply that by pi over 180. And if you want to multiply from radians to degrees, you will multiply by 180 over pi. Now, if you can have your unit circle handy there. Now, you will just start to know these after a while. And I'm going to teach you how to be able to draw the unit circle by only using radians. Because next year, the only day we use radians, degrees, is lesson 1, lesson 2. After that, and there's 2 units of trig next year. So all we do is radians. All we do is radians, okay? So you're learning a language that obviously the other grade 11s won't have going into next year. So say you decided not to be in AP next year, you went in a regular Math 30 classroom, right? You would now see the difference between never seeing this stuff before and of spending a few days on it, okay? And this will even make you better for the final exam that we're doing this year. So there's a lot of benefits for you to be able to go through this ahead of time instead of seeing it for the first time next year. And let's face it, next year's the mark, the only mark that universities are using. They don't care about your grade 11 mark. Okay? They don't go back to your file and look at grade 1 that you were wetting the bed and stuff like that. They don't look at any of that. Okay? They look at grade 12 diploma. So same thing with universities. Guess what you get your scholarships off of university is your first year marks in university. Do you know after you do your first year university, they never look back at your high school marks again? It's kind of like the last year you ever do, right? So whenever I have students that do well on the AP exam, and they're like, yeah, I can take credit, I don't have to do calculus next year, I go, take calculus next year, trust me. It's worth money next year if you do it. Okay, it's just an option in high school. Like literally, Math 31, drama, dance, they're all options. Okay? So taking Math 31, it's just an option in high school. Take it again in university, get 100 on it. It's like worth money. Like, you know, like getting a good mark in a university class, it's huge. Same thing with next year, when you're doing this for the second time, your diploma mark will be better if it's your second time. That's the time that it counts, right? So it's really nice to learn stuff the first time when it doesn't hurt. Okay? So if you, put in 100% these next 4 days, yeah, it'll be harder work for you than the person that doesn't, but then next year you will have the greater advantage and you'll do better on your unit test and on your diploma because of it. So you really do win a lot of ways by taking the time to do these 4 really well this year. Now, 270, what is that on your unit circle in radians? 3 pi over 2, okay? But you don't know your unit circle yet. You've just been starting, and now you look at 270. Now it says, to convert, you multiply by pi over 180. And you'll notice that whenever you're going to radians, it will have pi in the answer. So then all you do, you see the 270 divided by 180? Okay, so with your calculator, all you do is take your 270 divided by 180, you just go like that. Do not mess with the pi. Leave it there and just go math, enter, enter. Now, if your pi stays there, do you see how it would? The answer is 3 pi over 2. And if you look on your unit circle, it's 3 pi over 2. Okay, 315 degrees. Let's multiply by pi over 180. Now let's just reduce the 315 over 180. Leave the pi behind. What do you get? So 7 pi over 4. Now, honestly, I know where 7 pi over 4 is on my unit circle way more than 315. Okay? And when you get good at it, radian measurement is way, way nicer to work with. The longer you hold on to degrees, though, the less chance you have of being successful with it. Now, when you look at something like 70 degrees, okay, 70 degrees isn't on the unit circle, so it just says do it to the nearest tenth, right? But then we would just multiply by pi over 180, and then you just go, now you got to make sure, you got to be really careful that you actually do your top in brackets. So you got to go 70 times pi. Actually, it's more important that you do the bottom in brackets if there's 2 things, but it's still a good habit. Or you just go 7 pi. Pi's there, right? Oops, I got an H. 7 pi divided by 180, and you get, okay, oh, 70 is my problem. Oh man, I'm not having a good day. Second insert. Okay, so 1.22. So this is 1.22. Now, if you just leave it as 1.22, or you could write 1.22 radians. Since radians is the accepted mathematical way of doing angles, nothing always means radians. Like if you just put an answer of 70, I mean 70 radians. Like you have to put a degree sign to mean degrees. You don't have to put anything if you're meaning radians. So you could do either one of these. They both mean the same thing. Okay? And you could just do B the same way. Okay? Just do B quick. See what you get. How many radians? Mm-hmm. They're over there. Okay, so what do we get? 3.6 rad. Okay, yep. Doesn't matter. Not till we start using sine, cos, and tan. But if you're using sine, cos, and tan, if you're putting in degrees, you have to be in degree mode, but radians in radian mode. Okay? So people always get freaked out about that, but unless you're using sine, cos, or tan, doesn't matter what mode you're in. Okay? It still works good. Now, convert the following from radians to degrees. Now, have you ever seen a degree with a pi in it? No. So that's here, because some students get mixed. Oh, should it be pi over 180, 180 over pi? Get your pi's to cancel, so that's why you know to go 180 over pi. Do you see how there's one in the top, one in the bottom? So that's how you make sure you don't get those formulas mixed up. And then you just go 180 divided by 4, and that works out to be 45 degrees. Okay, this one here, again, if you multiplied by pi over 180, do you see how the pi's won't cancel there? Like, that's how you know you won't screw those formulas up. Okay? But work on your formula sheet too for this, because if you or your study sheet, because that study sheet you'll get to use for next year, right? Don't throw it away, because we've only we're going to be continuing on from here. I'm going to do these 4 objectives again next year. Okay? So then that's still, if you've got your study sheet done, and then you can use them for your quizzes the next few days and have that with you. Okay? Now these here, the pi's cancel. You'll go -7 times 180, divide by 3, and you'll get -420 degrees. Okay? Now, this is almost like these juxtaposition each other, because 1.57 radians, like it's almost, radians are so exact that you gave me this rounded number, right? So you really you'll never see this in real life. There'll always be a pi in there. But it's like introductory, so get them learning how to convert back and forth. But because we're in radians, we're going to change the degrees, and we're going to go 187 over, or 180, sorry, over pi. Right? And this works out to be 90 degrees. Okay, because radians, 1.57 is pi over 2. Okay, -1.4, again, just multiply by 180 over pi, and we're going to get -80.2 degrees. Okay, now, here we're going to do a little bit of review. Coterminal angles are angles with the same terminal arm. They are separated by a multiple of 360 or 2 pi radians. Okay, so if I gave you this angle here, say that one, if I added 2 pi to it, I would come back to where I was before. And if I added another 2 pi, those are all called coterminal, because they all terminate in the same place. Okay, and again, that is review from when we did trig earlier. The principal angle is a set of coterminal angles, of a set, I should say, is the smallest positive rotation angle. Okay, so if this was, say, what would be a good one? Yeah, pi over 3. Okay, pi over 3 is the principal angle because it is the smallest positive rotation. No, the principal angle is between 0 and 360, or between 0 and 2 pi radians. Now, let's see if we can do this using our radian measure. So rotation angle. Remember, we had our 4 rotation angles. So if we were, say, here, the reference angle just equaled the reference angle. What was the reference angle? It was that angle between the x-axis and the rotation angle. Now, if we were going to do this angle, and if I found the reference, how would I find the rotation? It was 180 minus the reference. Do you remember that? So if we were in radian modes, it wouldn't be 180 minus the reference. It would be pi minus the reference. And if we were in this quadrant here, we would go 180 plus the reference, right? Now we're going to go pi plus the reference. And if my rotation angle was over here, this would be the reference angle. So before we were doing 360 minus the reference, now we're going to be doing 2 pi minus the reference. Okay, so you're just kind of learning a different language at this point, not really learning any new concepts. Now, it says in each of these, draw the angle in standard position, state the principal angle, and determine one positive and one negative coterminal angle, and then write an expression to represent all the angles. Okay, so we're into dealing with radian measurements. Okay, now here's kind of something that I'm going to teach you a lot more in detail, but if it's over 4, you count as every quarter. So that's 1, 2, 3. This is 3 pi over 4 right here. And if you look on your unit circle, it's there too. And then this would be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, that's how you count your over 4s. Okay, so 3 pi over 4 is right here. Now the first thing, well, it says draw it in standard position. State the principal angle. Well, the principal angle is 3 pi over 4. So 1, we did it. 2, the principal angle is the smallest angle from the x-axis. So 3 pi over 4, or the original. Okay, and it says state one positive and one negative coterminal angle. Well, if I want to find another coterminal, what do I do to that? Right, so 3 pi over 4 plus 2 pi. Now, the bad thing about these is we always got to find a common denominator. Now, 2 pi is the same thing as, so 3 pi over 4 plus 2 pi would be 8 pi over 4, right? So then the answer would be 3 plus 8 is 11 pi over 4. Now a negative coterminal would be 3 pi over 4 minus 2 pi. So that would be 3 pi over 4 minus 8 pi over 4, which would give you negative 5 pi over 4. Now, 4, kind of ran out of room here. It says, give an equation for all the coterminal angles. So you'd go 3 pi over 4 plus 2n pi. And then we do this one last thing. We say n can be an integer. That means I could put 1 or negative 1, 2, negative 2, 3, negative 3. I could be going both ways. Okay? So the n is an integer only, gives you that. Okay. Let's do b quick. Okay, so negative pi over 3. Now, negative pi over 3 is the same thing as negative 2 pi over 6. Now, why am I telling you that? Well, my pi over 4s go every 45 degrees, just like I showed you. The rest are all pi over 6s. And just watch this so you can see. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9, 10, 11, 12 pi over 6s. So the only things you really have to remember is all the ones divided by 4 and all the ones divided by 6. So anything over 3, put them over 6s. Okay? So I got negative 2 pi over 6. That would be, so I'm going to go 1, 2. So this is negative pi over 3 right here. Okay, so what is the principal angle? The principal angle is this one here, right? This is the principal. So you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the principal is 10 pi over 6. Now, that always gets reduced to 5 pi over 3. You always have to reduce your fractions. Okay, how do you find a positive coterminal? Well, go 5 pi over 3 plus 2 pi. Now, that's got to be a common denominator. So what would be 2 pi over a common denominator of 3? 6 pi over 3, or over 2, right? Over 3, sorry. 6 pi over 3, right? Still is 2 pi, but now 5 plus 6. So the answer would be okay, 11. Okay, so 11 pi over 3, and then if we did 5 pi over 3 minus 2 pi, that would be 5 pi over 3 minus 6 pi over 3, which would be negative pi over 3, which was our original question anyway, right? So we might have to go again to do another one. But the general solution is the principal angle, which is 5 pi over 3 plus 2n pi, n is in the integers. Okay, now we're going to be determining reference angles. What's reference angle? Who remembers? Yeah. The smallest angle to the x-axis. So 4 pi over 3. Now, because if you don't count by 3s on unit circle, so this would be 8 pi over 6. Okay, so you go like this. 1, 2, 3, 4, 5, 6, 7, 8. This is where I am, right here. So what's the reference angle? It's right there. What is it? How many pi over 6s? 2 pi over 6s, right? So count them. 1, 2. Which is, reduces to pi over 3. Okay, so negative pi over 4. Now I'm counting by 45s, number 1, and I'm counting backwards. So 1, 2, 3, 4, 5. That is negative 5 pi over 4. So what's my reference here? What's that reference? This is pi over 4, right? Okay, and 23 pi over 6. That's just ridiculous. Let's not do that one. Okay. Next thing we're going to talk about is arc length. Now this is always a diploma question, okay? They'll have one of these on the diploma. Now, the way arc length works, we're basically swinging something. Okay? We want to know how far it's traveling. So if you tell me what the radius is of the string and the angle that it goes, I can tell you how far that traveled. So that would be good for doing your planets around, like what is the actual distance the Earth does finally go around the sun, right? That's all done by this formula. They didn't actually measure it. Okay? It's pretty hard to measure. So, and this is how I just remember it. It's like arrow. A equals like R, it's theta, but it looks like an O, right? So you have your arrow formula. Just remember, this is huge. This is where they will get you on the diploma. Theta must be in radians for this formula to work. 9 times out of 10, they'll give you the degrees, and you'll shove degrees right into that formula, and you'll get the wrong answer. You must convert from degrees to radians, and then you plug it in. Very simple question, but students who don't do that one thing get it wrong. Okay, let me show you how the formula works. A pendulum, 30 centimeters long, swings at an arc of 45 centimeters. Through what angle does the pendulum swing? So here is where it's attached. It's on a 30 centimeter string, and it does an arc of, oops, that was a really bad arc. Does an arc of 45 centimeters. Right, that's it, the arc length. Now it wants to know at what angle did it swing. Okay? Wants it in degrees and radians. What will the answer give it to me in? Radians. Okay, you have to know that. It's not going to be on the diploma anywhere. That's not going to be told to you. So, here's our formula. A equals R theta. We're trying to solve for theta, so we're going to divide both sides by R. So A over R equals theta. Now, A stands for the arc length. That is 45. The length of the string, okay, so a pendulum 30 centimeters long, that's where you get your 30. Okay, when you get you will get 1.5. Now remember, that's one piece of pizza plus a half of another, or pie or whatever, right? So you got to be thinking what 1.5 radians are. Now remember, this means rad. How do you convert to degrees? You go 1.5 times 180 over pi, and you'll get 85.9 degrees. Okay, so not hard, but if you've never seen it before, it's weird. Okay, calculate the arc length. This is diploma question, right? This has been on a diploma. I've seen this exact question on the diploma. Calculate the arc length. So arc length is always this, right? Calculate the arc length to the nearest tenth of a sector of a circle with diameter 9.2 meters. So we've got a circle. We've got this as 9.2 meters. Okay? It wants to know if this thing went here and it went 150 degrees, so 150 would be about there, correct? It wants to know this. Okay, now A equals arrow. What do I know? What's the radius? Yeah, the radius is 4.6, right? Not 9.2. 9.2 is the diameter. So that's one thing they'll catch you on. The next thing is we need to know the theta. You got to go from degrees to radians, so pi over 180. So the 150 divided by 180 works out to be 5 over 6. So 5 pi over 6. So now using this formula, I should put degrees there. Arc length equals radius is 4.6 times 5 pi over 6. Now make sure you multiply by the pi, right? So it's 4.6 times 5 times pi. You can hit enter if you like, and then divide by 6. So 12.0. The arc length is 12.0 meters. Okay, one more question. It'll always ask you, so it's funny, but math doesn't use significant digits. They will ask you, it's nearest tenth, right? Physics is big into significant digits. Math, we don't teach it at all, right? Which you would think that's where it comes from, right? Math has different rules. Okay, so you got to do what they ask. Now, a circle with center C and a minor arc. So you're always going to have, whenever you have a circle, okay, and say this is your, right, and see how we've got two arcs? We've got this arc and we've got this arc. The smaller will be called the minor, and this will be your major. Okay, so minor is a small arc. There's always two arcs when you have a circle and you draw an angle, you take a piece out of it, right? There's going to be the small and the large. So it says, find the length of the radius of the circle to the nearest tenth of a centimeter. So it says this minor arc here is 15.2 centimeters. Now it says if angle ABC is pi over 6. Now which angle are we talking about? It gave me 3 letters. B, good. So this is pi over 6 here. And it says that angle BAC is pi over 6. So it's giving me like two concepts at one time. It's talking about this triangle and it's talking about this arc formula. Now, why does knowing those two angles help me find the radius? Like we have this formula, and this is what I'm supposed to find. So let's divide by pi, or divide by theta. So A over the angle equals the radius. This is R right there. So we know A, we don't know R, and what else don't we know? Because if you look at this, see how this is the pendulum swinging? If only we knew this, we could do this question, right? How can you get it? Okay. What do you know about a triangle? The equal 180, or now you know it equals pi. So all angles of a triangle equal 180 degrees, but now you know they also equal pi radians. Okay, well we would have to go pi minus pi over 6 minus pi over 6, right? So we're going to change this to 6 pi over 6. So 6 pi over 6 minus pi over 6 minus pi over 6 equals 4 pi over 6, which equals 2 pi over 3. Because pi is the angles of all of a triangle, and I needed a common denominator. So pi is the same thing as 6 pi over 6, right? Because all angles of a triangle equal pi. So if I take pi minus pi over 6 minus pi over 6, I'll get this angle here. And so I did pi, well I can't minus pi over 6 from pi. So I did a common denominator, because 6 pi over 6 is pi, right? So I got 2 pi over 3. Now I can use my formula here, because if you come back here, it says A over theta equals radius. So now if I go A is 15.2 divided by 2 pi over 3. And anyone, see if you can get it in your calculator. Find out the radius of our circle. What is it? 7.3 centimeters. Okay, so this is the type of question you'll see in the diploma. Which, for you, when you hear that right now, it shouldn't cause much anxiety. That's a long time away. But the next time when you hear this will be on the diploma. This will be the, because we're going to do these same notes again next year. Right? You're going to write the same quizzes again next year. Your chances of success compared to others that haven't done it before are much, much higher. Okay? So can you kind of see how the radians are working now? Okay? You do have it on your unit circle, so they're on there so you can become familiar with them, and I've kind of tried to teach you how I use it. But try your best to be counting by 6s and counting by 4s to get those, and you'll start to wean yourself off of degrees yourself. I know from personal experience it's not easy, because you're so successful with degrees and you get them and the whole thing, and now this weird thing's coming. But it's weird, the longer you hold on to degrees, the more confused you'll be with radians. Okay? So you got to kind of force yourself. So yeah, 1 to 6 ACE, ... and then 7 to 17.